Hello everyone, I'm Shreya and I'm going to be talking about the basics of web development in this video. And I'm going to be doing this through a real project that I built, a spin the wheel app. The app looks something like this. So you add names that you want and you spin the wheel, and obviously the pointer lands up on a single person and that person wins. It's simple, but before we look at any code, let's look at how this web app has been put together and how everything works in it internally. So we first have the front end, which is the browser or the UI that we just saw, where we could click on the spin the wheel or add names and so. And then we have a server, that's the back end, and then we have the database. So you can think of a web app like a restaurant actually. So the front end can be related to a dining room where customer sees and interacts with, and the back end can be like the kitchen where all the work is done behind the scenes, and the MongoDB, that is the database, can be thought of like as the pantry where all the ingredients are stored, and in our case that would be data, and it's even like kept safely. So what actually happens when you visit the website is the browser, in our case the Brave or the Google Chrome browser, it sends an HTTP request to our server, and in our case that would be our local Node.js server that we have built. And what the server does, or what the backend does, is it receives this request and then it talks to MongoDB, which is our database, and looks for whatever data is required if needed, and then it sends back a response to the browser with whatever data that was asked. So we can think of this like a customer placing an order. So that would be the request, and then the Express receives this request, talks to MongoDB, and sends back a response, which would be the food plated. And in our app specifically, so the wheel is drawn in the browser using HTML canvas. So when you save a wheel, like let's just save these names as default wheel. So what really happens here is this data, that these names and this wheel name, it travels through the Express API and then it gets stored in the MongoDB. So when you come back next time, so let me just quickly refresh this. These are like the current saved wheels. So when you come back to the website and click on these wheels, it would fetch it. So Express in this case would fetch this wheel along with the data related to that wheel, and the browser would load it right back up. So for any website to be fully functional, it is actually an entire system that's been put together and that works simultaneously while communicating with each other that makes this particular website functional. And even if like a single link is broken between each of these parts, the website wouldn't work as intended. So now let's look into each of the parts that are in this system, and let's see what each of them do. So firstly we have HTML. HTML is like the skeleton of every web page. It basically gives structure to our website or web page, and in this case we can see there's a nav bar that says spin the wheel, and then we have like a canvas ID which says wheel, and that's like for the wheel itself. And then we have a button that says spin. So while this code here doesn't exactly um, give us our like the end UI, the final UI, it acts more like just the bones and no style, no behavior. So it's gonna tell you where which element or which component should be placed. So that, which is why it gives structure and a good layout to our web pages in a website. And there's a lot of elements that we can make use of, that can be used with meaningful tags like we've seen here. Coming to CSS, this is what actually makes our web page look good. So the HTML acts like the skeleton. Then you can say that the CSS is kind of like the muscles and the skin. So we use it to set colors, fonts, spacing, and animations. So you can, as you noticed, the dark theme, the red borders, and the glowy effects, and all these different colors and the font, literally everything that you see here, anything related to the style of this web page, has been done using CSS. So yeah, we write custom CSS and the way we want, and that would make our web page look a certain way. Coming to let's go to Bootstrap actually. Bootstrap is actually a CSS framework, so that is basically a toolkit of like pre-built styles and components. So in case of Bootstrap, we get like pre-built styles and components that we can directly use, and instead of writing a nav bar from scratch, or a modal or a responsive grid layout all from scratch, Bootstrap gives these to us for free. So in our app, we use Bootstrap's grid system. So as you can see here, the wheel and the controls, so this will be the wheels and that will be the controls, they were like, these particular divs were laid out with the help of Bootstrap's grid system. So we've used like row G4, which is greater, or like column LG, or like large in size, 7. So that gives this specific look to our wheel div and the controls div. And the next part would be JavaScript. Now, JavaScript is kind of like the brain of the front end. While HTML is the structure and CSS is the style, JavaScript is what makes things actually do something. So in our app, JavaScript does 3 big jobs. First, it draws the wheel using the Canvas API. Every slice, every color, literally everything is drawn by the JavaScript code running in the browser. And secondly, it handles the DOM manipulation. So when you add or remove a segment by adding or like deleting a name like that, the JavaScript is what updates the list on the page in real time without reloading it. So it's like a front end communication sort of a thing. It basically is what makes a front end responsive. And secondly, it also talks to our backend using the fetch API. So when you hit save, the JavaScript sends a post request to Express with the wheel data as JSON data, and we use the async or await throughout, so none of these operations actually block the page while they're still running. So you can think of JavaScript as, not just as a mere coding language, but also as like the brain of the front end, and also as, as a means of communication in this system of our web app. Now, moving on to Node.js. So Node.js lets us run the JavaScript outside of the browser on the server. So before Node, JavaScript only lived in the browser. So if you just had like a front end index.html page and some CSS file, and a JavaScript file that like tells the browser what to do based on a few clicks or like whatever, like however the user interacts with the web page, then in that case, that particular web page would only be running on the browser. But with Node, we have our server running on our local machine, and Node is what powers our backend. It's the runtime that executes our server.js file, and on its own, Node is pretty bare bones, which is why we pair it with Express. Um, Now moving on to Express. Express is a framework for Node that makes building web servers a lot more simpler. In server.js, we define 4 routes. That is get all wheels, get one wheel, post to save a wheel, and delete to remove one, and get is nothing but to retrieve. And in this case, wheels would be data from the database. So each of these routes is actually a function that um, receives a request and sends back a response. Express also serves our entire public folder, that would be this, that contains the JavaScript file, the HTML, and the CSS file, as static files, which means it's what delivers our HTML, CSS, and JavaScript to the browser when you visit the website using the link localhost 3000. And finally, coming to MongoDB. MongoDB is actually a NoSQL database, which is basically like instead of rows and columns like in SQL or MS Excel, it stores data as documents that look like JavaScript objects, and which is nothing but in the JSON format. So each saved wheel in our app is one document with a name, a created at date, and an array of segments. And Mongoose is the library that we use to connect Node to MongoDB. And that lets us define a schema, which is basically a blueprint of what our data looks like. It also gives us clean methods like find, save, and find by ID and delete, and so on and so forth. And this here is exactly what a piece of data or a document in our MongoDB would look like. Now let me take a deep dive into Express and REST APIs. So what exactly is Express and why do we need it? Let's start from the beginning. So when a browser wants something from a server, it sends an HTTP request, and then that request has a method like post, get, delete, etc., and a URL. So now the server needs to receive that request, figure out what it's asking for, do some work, and send something back. So Node.js on its own can do this, but it's extremely low level. You have to manually parse the URL, read the request body, set response headers. It's a lot of boilerplate code for something very basic. Express is actually a perfect framework for this exact job. It sits on top of Node and handles all of this for you. It gives you a very clean and simple way to say, when this URL is hit with this method, do this. You don't have to, you know, set up any response headers or manually parse the URL, anything like that. Express does all of it for you. So that's pretty much it at its core. Let us now take a look at how Express is actually set up in our project. So when you when you look at this part and this part, line 2 and 4, and 7 and 9, 7, yeah, 7 to 10. So these first few lines are basically this and this would be the foundation of our entire server. We import Express here, and then we create an app instance here, and then we register middleware. Middleware is basically a code that runs on every single request before it reaches your routes. You can think of it as a conveyor belt, and that's like every request passes through each piece of middleware in order. So the middleware here would be cores, and cores here basically allows our front end to talk to our back end across different origins. Without this, the browser would block the request for security reasons. And then we have app.useexpress.json. Express.json is super crucial. It tells Express to automatically parse incoming request bodies as JSON format data. Without this, request.body would be undefined and we'd never be able to read the data from the data our front end sends to us. And then we have the express.static function where we have our dir name, it's public. So this basically tells Express to, automatically serve any file inside our public directory. So when the browser asks for index.html or style.css or app.js, Express just finds the file and sends it back without us writing a single route for it. So that's pretty much the foundation of Express that we've laid out here. Let's look at what REST REST is. So before we look at the routes, we should talk about REST, which stands for Representational State Transfer. It is not a library, it is not a framework, but it is actually an industry standard, or it's a set of conventions where a way of designing APIs is laid out by. So the whole industry uses this particular set of conventions and designs APIs in the same way. So the core idea is that everything in your app is a resource. In our case, a wheel is a resource, and HTTP already gives us 4 verbs to interact with such resources. So we have get to read, post to create, and put or patch to update, which in this case has not been implemented but can be used, and delete to remove a view. So REST says that you can use these four verbs and organize your URLs around your resources like this. So instead of having URLs like slash get wheel or slash delete wheel, which is what people used to do, REST says your URL should just be slash API slash wheels, which is nothing but just indicating where our resource is, and and then the HTTP method tells you what you're doing with it, like get to that URL means fetch all wheels. So, and then if you have get API wheels ID, then that means like just fetch one wheel. So REST is basically clean, predictable, and every developer who's worked with APIs immediately understands it. Now, when we look at all our routes in our code, sorry, yeah, that will be here. So when we look at this particular route, so what this does is it retrieves all the saved wheels. So when you're looking at this saved wheels part, so this these the default wheel and the web dev wheel are the two wheels that exist in our database, and both of them are retrieved and displayed here, and that is done in the backend with the help of this particular route. And when we click on a particular wheel, let's say the default wheel, and then we have all the data in the default wheel displayed here. So what happens is it fetches it, it gets the particular ID of that default wheel and fetches the data from this particular wheel and displays it on our front end. And when you say app.post API wheels, it just saves a new wheel. And we have app.delete wheel, where you can delete a specific wheel that has a particular ID. That's pretty much it about row. So to put all of it together, I can tell you that, let's say, okay, let's just add a new wheel, N1, N2, N3, and let's call this a demo wheel. So here, when I hit the save button, what exactly happens is, first the JavaScript in our browser calls fetch API wheels, where your method is given as post and body is JSON. So that creates an HTTP post request and it sends it to our server. So I've hit save here. Okay, and before it actually displays here, the server takes that post request, passes it through our middleware, which is course, that checks the origin, and then goes to Express.Json, parses the body, and then Express matches the URL to our post wheels, and we valid inside, and then inside this callback, we validate our data, and then we call the save function. So this is actually a this is when the mongoose model is created, and this is like translated into a MongoDB insert operation. So what happens in MongoDB is that it stores the document and returns it. So Mongoose hands it back to us, and then when we send it to this, and then it sends it to the browser as JSON with a 201 status. So the whole round trip takes about maybe like 50 to 100 milliseconds, which is why the demo will display as soon as I hit save. Now I can just add another name and hit another save, and you see how responsive it is and how quickly the second wheel got displayed. And if you click on each of these wheels as well, it it calls the get API wheels ID route, and it fetches the required data from the MongoDB. And from the front end, all we have to do is wait the fetch call and parse the response. So that clean separation between the front end and the back end connected through a simple HTTP API, that's basically the architecture of every web app you've ever used. Now let's look at how Express is used and why it's. So let's look at an example of how Node.js can build servers, but the code gets messy and verbose really fast, but Express just simplifies it. So let's build a very basic server that just prints hello world. So what we can do here is code, yep, and let's build a server file. So with the help of just Node.js, our code would look something like this, right? And we have to put the server in and say http create server using request and response, and this function would return if the request, not the URL, it's like this, then you write a response. So you're basically building the response. First goes the response header. We have a positive status code showing success, and content type would be plain text. And then we can put the response data as well using rest.end, and we can write hello world, right? And then close that, and then close that as well. The function ends there, and then write a server out to listen with port 3000. So what exactly is happening here is we just built a server that listens in port 3000, and when the user goes to this URL, let's quickly do that actually. Yeah. Okay, so we have not added any console statement, console.log statement indicating that the server is running at so and so, but I know the port number is 3080, so we can just go to our browser and open up 3080, and we will see hello world with our little typo that we had included in the code. Let's stop this and take a look at our code actually. This is writing the code in pure Node.js. If we had to write the same code in Express, it would be something like this. Let's create a new server and do this. So then the code for this would be, we would first need require Express, and then we would need Express framework, and then we attach our first row, that is app.get. So instead of writing the whole create server and that looks for the specific URL, we're using the Express framework here and just writing this one row that says this, and we don't have to basically add the whole header or like the status code and so and create server. We can just get the request and send a response in this manner, hello world, exclamation marks, and then sorry, I missed the quotes here, and we should be done. Now we can just do an app. Sorry about that. App.listen. We can give a new port number, or just the same port number should work. Yes. Alright, so when I do node server 2.js, again we don't have any console log statement, so let's just go to the same web page because we use the same port anyways, and now let's hit the reload button, and we can see the new hello world with exclamation marks written by Express. So this would be it about the basics of web development and Express and REST API. I like the fact that I was able to build the spinner wheel to demonstrate all of these concepts that I've learned. And I also built this as something that you actually want to use at a game night with friends or family or some kind of a decision maker or something like that. But beyond the project, I want to leave with a mental note I call as a restaurant analogy for remembering how full stack web dev works. So every time you build a web app, just ask yourself, what does the dining room look like, which is our front end, and what's on the menu, which would be our API routes, and what's stored in the fridge or the pantry, which is like our database. And when you answer those 3 questions, you know exactly what to build. And of course, our kitchen or like our hero would be the backend that does all the job. Anyways, thank you for watching, and hope this video was insightful for you as it was for me.